Okay, hello and welcome to Friday in Chemistry. Today we have a few different things we're going to do today. Yes, we're going to do a Kahoot today. So doing what I can to make more fun things. We'll probably do another Kahoot on Monday. So this week we are working on this assignment, which is 5B AP for active practice. Stands for, that's what it stands for. And does it burn is what we're working on because we're talking about combustion reactions. There are 3 sections in this activity or in this practice. That is doing reaction models for combustion, oxidation, and decomposition. So those are the 3 models that we have. Then we have a section on equations. So the equations are, most of them have videos. So you can actually see the reaction happening and not just have to do a bunch of math. So you see some like excitement to do balancing reactions. And you also need to classify them. And then section 3, which I don't think we've gotten to in this class, is talking about covalent bonds and how sometimes the electrons in covalent bonds are shared, but not quite evenly, and what that means. So we're going to get into that today. So things that you need those reaction models, because for the Kahoot, I'm asking you to classify reactions. You need a periodic table because you always need a periodic table. A positive attitude because you always need a positive attitude. Creativity because sometimes when you're balancing equations, you got to think a little bit outside the box. And a device with internet, participation in Zoom, and a camera image of you. Okay, and also today I'm going to show you where some resources are on Google Classroom, namely Zoom recordings and also some things that I posted for extra practice and some reference. Okay, so first, focus question. This turned into good fun in first period, so I thought we'd try it second period. Make up your own question for focus question. Hopefully about chemistry. It can be any question you want, but you can put in a question and then put in your answer. And let's just see what we come up with. It could be a question you don't know the answer to. You can just post it in the chat and let's see what happens. Exactly. How good looking is Bilal? 1 to 10. Oh, here's a chemistry question. How many electrons does fluorine have? That's a good question to know. Do you know the periodic table song? I like the fact that 10 is the correct answer, and that is, well, which question are you answering, TJ? Is that 10 for Bilal's looks, or is that 10 for how many electrons fluorine has? Oh, the most useful element. That could cause a debate, that question. Thanks for clarifying. Oh, which section of the periodic table are transition elements? That's a good question. Where are they? Yep, they are in the middle. Somebody told me. Yeah, so right there, here's my periodic table on my phone, on my phone camera. So yeah, right here in the middle, we call these transition elements. These on the ends are the main group elements, and then these are in the transition. Yeah, we don't really talk about these a lot, but we'll see them more and more as we go forward. Any other burning questions we need answers to? So the question about how many electrons does fluorine have? Fluorine's over here. Actually, can I move it up into my camera so it's bigger? Yes, but then it'll be dark. So that doesn't work. So fluorine is in second period, all the way at the right, not quite to neon. It's atomic number 9. How many electrons does it have? Well, it depends. As a neutral atom, it has 9 protons, so it has 9 electrons. But it has 7 valence electrons, so it wants 1 more. So it would usually gain an electron and have 10 electrons for its 9 protons and -1 charge. How are atoms created? That's also a good question. We did that way back in September. You might not remember, but they were made in stars through fusion reactions, high gravity pushing particles together to make atoms. we, we have in response to which element is the most useful, we have someone claiming that astatine is the most useful and a challenge to change their mind. Why is balancing equations important in chemistry? It'll be important next week and the following week as we start to try to follow recipes to make something happen. You need to know how much of everything you need. So we'll be talking about balanced equations so that you can do that. Oh, we have a vote that oxygen is probably most important because it's everywhere. It absolutely is. It's important for us breathing oxygen, but it's one of the most, if not the most, I'll have to look it up, common element in the Earth's surface. Because every metal will react with oxygen in order to make an oxide. Sand and rocks are mostly silicon dioxide, so there's a lot of oxygen. Yeah, you see oxygen in a lot of places. It's also in water, and water is everywhere. Let's see. What is the strongest base metal? No reactions. That's a good question. If I look at my activity of metals, I think gold is super non-reactive, and silver, which is also why they were seen as being precious metals and being used for currency, because they don't react very much, they don't tarnish, so you always know that you have a pure substance. Platinum might be in there too. I would have to look at my list. All right, any more questions to kind of look at? Oh yeah, chromium. Yeah, that's a good one. Yeah, because chrome is used to plate a lot of things. Yeah, but I don't know if chrome plating is pure chromium or if it's an alloy with something else. So that would be a good thing to look up. All right. These were good questions. Here's what's happening today, a variety of items. We're going to take a quick look at the calendar. We looked at the calendar yesterday, but I want to look at it again. We're going to do a Kahoot about classifying reactions, so some practice. And then we're going to take a look at Does It Burn, which is originally due today, but depending on how far we get today, you may want to hold off on turning it in until tomorrow. I have some people that have already turned it in, so mileage may vary, and that's totally fine. Mostly, I wanted to check our answers about classifying equations and then also about balancing them, and then get into bonding types. There's a video that I want us to take a look at today. So we'll see how much time we have. I'm hoping to let you have time to work today, and I think we can get there. But just in case, if we don't get there, then you should certainly take the time over the weekend to do independent work, and you can turn this assignment in Monday. Speaking of, here is our calendar. So this is this week. We are currently on Friday, the end of this week. So anything that you want included in your progress report, you want to get into me today. So on the progress report, things that I'm counting are anything in topic 4. So 4A, 4C, and 4D, quiz number 4, and then just the first assignment with the lab that we did, does it mix, in topic 5. So this week's assignment, I'm not going to include that in the progress report. In fact, I even made it due next Monday, just in case it takes that long for you to do it. If you have not taken the quiz yet, you will get a not unfriendly, but not friendly reminder that you need to do the quiz. And a lot of you have taken the quiz. If you want to do a retake, you can. I think I've graded every quiz that has come in and retakes and return them to you so that you can get all of that feedback. Also, next week, we're starting a new assignment. This is going to be a lab. It's called Does It Blow Up? Yes, we are going to take a look at reactions that create gases. And if you create a large amount of gas in a very short amount of time, we get to call that an explosion. We're going to do a lab next week where we blow something up. Yes, you might remember in your kit, you got a balloon. and we're going to blow up that balloon. There are some materials that you need to gather for that. So not least of which is vinegar and baking soda. So you need to have those around. And then you also need a water bottle or a soda bottle of some kind that you can do your reaction in and then put the balloon on top. But we'll talk more about that on Monday when we're doing pre-lab. And I'll also send an email over the weekend to everybody's house so that you can make sure you get the things over the weekend that you might need.
When do the progress reports come out?
That's a great question, Isaiah, and I'm not sure. I know that the last day that I can record grades for progress report is on Tuesday. So I'm guessing that means they come out Wednesday. And I don't know for previous progress reports, have you gotten them in the mail? Have they mailed them to you, or has it been an email?
No, no, I was just asking when the progress reports were going to come out. That's all.
Okay. Yeah. And David, did you tell me that they think they come in the mail?
Yeah, mine did last time.
In the mail.
Okay. All right. Oh, so I have other people say, okay. I don't receive progress reports, so I don't know how they.
Oh, okay. Okay.
I know I have to turn them in.
Yeah. No, it's fine. It's fine. I was just asking when they were going to come. That's all.
Yeah. Yeah. So you know, when to do all your chores around the house and be really kind to your family, and when you want to have good conversations about, oh, I'm late on this assignment, but I talked to Miss Herman and I know I'm doing it right. Yeah, have all those positive groundwork conversations all next week. Okay. Oh, and last but not least, next Friday, we're going to have a quiz. Yay! Another quiz. Okay. That was a lot. All right. So let me show you some things, because the next thing we're going to do is a Kahoot, but you might want to know where you can find stuff to help you out. So let me look at Google Classroom. Oh, hang on. My screen is doing weird stuff. Let me share my screen again and do it this way. Okay. Oh, hang on. Okay. So here we are on Google Classroom. So where do I find Zoom recordings? They're right here in this material called Zoom recordings. If you go in there, there's a document, and the most recent things are at the top. So you will see that I put Tuesdays on here, but I haven't done yesterday's yet. Ms. Herman, you're slacking. I know. It's so embarrassing. Also, let's make this a heading so that we can tell since I'm here. So what you can see here is that the, oh my gosh, sorry, sharing a screen and trying to do stuff at the same time on Google Classroom is so painful. Okay, I'm gonna stop. So you can see that there's a Zoom recording for first period and for second period. You can watch either one or both. Sometimes I have the slideshow from that class as well, so you can see what the slides were. And also I kind of describe what things we talked about, just so you go, wait, I'm working on this assignment. Where can I find information about it? So you can go in here and find out where it is. Yeah, and it goes all the way back. I think it just goes back to February 1st. Yep, there you go. You can go back in time and look at all those things. Okay, so that is where Zoom recordings are. Okay, come on, mouse. Just thank you. So right under Zoom recordings. Here under reference, there's something that might be really helpful to you for the Kahoot. Down here, I have a document called Reaction Models. It's been there, but now I have it updated. So if I look at reaction models, I can see I have a model for every one of these. Now, if we were in the classroom, this would be a poster that you could always look at. So that's essentially what this is, a document that's a poster you can look at. So we have our model for single replacement, double replacement, synthesis, where we're taking things and making one product, and then combustion for this week, combustion inorganic, also known as oxidation, where oxygen gets to react with everything. And then the last one, decomposition, opposite of synthesis, where we start with one reactant and it breaks apart into its components. A lot of explosion reactions are decomposition reactions. Okay. And I think I will wait to tell you about the third helpful thing, because I already told you about two things. All right. So for the Kahoot, you want to have reaction models with you. either your own or this document called reaction models. You can kind of look and decide which ones go with which. It is right now 10:51. Let's aim at, if you wanted to print this out, you could print this out. If you have stuff to gather, I'm going to give you time to do that, as well as time to take a break because I've been talking for 20 minutes. And let's plan on being ready to start the Kahoot at, let's do 11 o'clock. That'll give us enough time to gather notes as well as print anything out that you want to get to print out and take a break. Sound like a plan? Okay. So I will see you in 8 minutes. And let me. Okay, sorry, I have to censor this name. Come up with something else to do with Inderpreet's name if you want to play. That's too close to an inappropriate word. All right. So I'm back up to 17, 18 people. Okay, 19 people. All right, let's get started. Here's our first reaction. What kind of reaction is it? I have a picture that's supposed to look like chips, plastic chips. Okay, it doesn't keep the picture up there, so I'm going to put the picture up there. There we go. So yes, this is single replacement. Ways that I can tell, it starts with one element by itself, and at the end, it has replaced one of the elements and stuck it out here. So that's one way that we can tell that it's single replacement. All right, good work. And let's go to question number 2. What's happening? Okay. A lot of people chose decomposition. That's the right answer. Let me get the picture of it back up here so we can look at it. All right. How can I tell if it's a decomposition reaction? Well, I'm starting with one thing, and then in the reaction, I'm getting other things that are pieces of it. I don't know what this thing was, but apparently it broke down into 2 compounds. So that's one way that I know it's decomposition. Okay. Let me move this off my screen and oh, a lot of movement in our quiz. All right, let's take a look at the next question. Hey, yes, this is a synthesis reaction. And I'll put it back out here so we can look at it. In fact, it's the exact opposite of that decomposition reaction we just previously had. I have only one product, and I have some things that combine to make that product. So we know this is synthesis. Okay, from now on, we're going to see things that have chemical equations, so chemical formulas and symbols in them. Also Indeprete moved into first place, and Indeprete's in second place. Gosh, doing such a great job, Indeprete. Okay, for this one, I have hydrogen gas, chlorine gas, and together they're making hydrochloric acid. Probably a gas too. Okay, this is synthesis. Oh, a lot of people chose double replacement. That's not actually a bad answer. So what's happening here is we're looking at synthesis because it's making one product. And so I have some things, technically these are elements that are being put together to have one product. I see a lot of answers with double replacement, and I'm going to say that's not a terribly bad answer. I mean, I do have a pair of hydrogens and a pair of chlorines, and they are switching partners. So they each end up with one hydrogen and one chlorine. I could see that. But this is more accurately called a synthesis reaction because it has one product that I'm making. All right, move my picture off the screen. Let's go to the next one. Okay. Okay. So here I have magnesium chloride reacting with zinc oxide. And I end up with magnesium oxide and zinc chloride. All right, double replacement. You can kind of tell just because there's so much going on with it, right? So I have two compounds to begin with, magnesium chloride and zinc oxide. At the end, they've switched partners. So the magnesium ends up with the oxide and zinc ends up with the chloride. Okay, and okay, let's see what we have here. All right, answer street 4. Nice. Let's see our next reaction. Oh, sorry, I was reading these up. Sorry. Calcium bromide and chlorine. In the end, I have calcium chloride and bromine. Okay, this is a single replacement. Let's take a look at it. So I start out with calcium and bromine together, and chlorine is by itself, so it's single. And then it comes in and it kicks out the bromine. So in this case, I have a non-metal kicking out a non-metal, chlorine kicking out bromine. So bromine ends up by itself. So single replacement, a clue to look for is there's a single element by itself. Now, technically, yes, these are diatomic, right? So I have Cl2, but it is just one element. So even though it's two atoms, it's still one element. So that's what we're looking at when we're looking at single replacement. All right. All right, more movement in our answer streak. Here we go. All right. Miss Herman, you didn't read this one aloud. You're right, I didn't. I'm so sorry. Okay, this one has 2 right answers. Let's take a look at it. All right, this is one of our new ones. So this is combustion. also known as oxidation. Why? Because oxygen is one of the reactants. So oxygen by itself is one of the reactants here. So what I'm starting with methane, CH4. I'm burning it in oxygen, and I get out carbon dioxide and water. So one of the key things to know is that a combustion reaction is I have carbon dioxide and I have water. Technically, it's also oxidation because anytime I have oxygen as a reagent on the reactant side, it's called oxidation. Combustion is just special oxidation. Okay. All right, let's see the next one. Okay. All right, for this one, I have silver nitrate and sodium hydroxide. I'm getting silver hydroxide and sodium nitrate. Okay. Yeah, double replace. Now, actually, oxidation is a pretty good run answer because there's a lot of oxygen going on in here, right? I mean, take a look at it. There's an oxygen and nitrate. There's an oxygen hydroxide. So every one of these has an oxygen in it. So that's a good decoy. But none of them have oxygen with just itself as an element, right? Like it's in all of those compounds, but I don't have just pure oxygen reacting. So it's not oxidation, but a good decoy. Yes, this is double replacement. You can kind of tell because I have two compounds in the front and they're each made of two things. These are polyatomic ions, nitrate, hydroxide, and they swap places. Okay, let me move my thing out of here. Okay, come here, you. We can go on to the next page. All right, so we have two more questions left. Wow, Indepreet hasn't even been in this class, and she's got 4 out of the 5 places. It's amazing.
I'm gonna let you in on something.
Yeah.
The reason why you see a lot of Indepreets is because people thought, let's confuse the hell out of the teachers. With 40 Indepreets inside the class.
Oh, really? Oh,
yeah.
It worked. I was completely fooled.
And that grew into a trend for at least 2 grades.
Oh, is that true? So Indepreet has been.
Ask
it has
anybody that's been in the previous classes.
All right. Well, that's okay. So we have 2 more questions. Let's try this out. All right, 9. I have tin. That's right. SN stands for tin. Its old name is stannous. So I have tin plus oxygen makes tin oxide. So what kind of reaction is this? Hey, look at that. There's 3 different right answers. Everybody got a right answer. Here, let me put this up here so we can take a look at why. Okay, so most accurately, this is an oxidation reaction because oxygen is one of the reactants. It's right there all by itself. However, it's also synthesis because I only have one product. I have things that are being put together to make one product. So it's also synthesis. So it's definitely synthesis, then even more precisely oxidation, and technically combustion. We tend to use that word combustion just for things that are organic, but non-organic things will react with oxygen as well and burn. So it is also combustion. This particular reaction doesn't produce a lot of heat and light, but you wouldn't necessarily know that unless you've worked with it. So yes, all 3 of those are appropriate answers. Okay, and our last question. Here we go. Amazing. Okay, here we go. So here I have calcium carbonate reacts to make calcium oxide, and carbon dioxide. Good. Yep, oxidation and combustion are also good decoys. Let's take a look. All right. It does really feel like combustion, doesn't it? Look, I have carbon dioxide as one of the products. There's oxygen everywhere. There's carbon out here. Yeah. It's not really combustion though, right? Oxygen by itself is not a reagent in there. Also, I only have one product. And that's the classic sign of decomposing. That is, I'm starting with one thing and it's breaking up into more parts. Okay, so let's get this out of the way and let's see how everyone did. Interpret won 3rd place. Brain Dead won 2nd place. And also Interpret won 1st place. And Interpret's also runners up in 4th and 5th place. Wow, Interpret's going home with a lot of prizes. Nice work. So silly. All right, let's say you had so much fun doing this that you wanted to do some more practice. Oh, hang on, I lost my, here we go. I lost my page. All right, so let's take a look. Here I am on Google Classroom. And if I come down here to equation and reactions, I see there's a new thing here called 5 practice. So here's a place where you can find some things to practice. So here is the assignment or the little handout. If I open this up. So these are the 10 questions that were on today's Kahoot right here. Oh, I have 2 copies of it open. That's just going to make, okay, so here we go. So here are the same things. These are the choices. So what you can do is you can practice doing all of these and then look at the answers to the Kahoot. I will post answers to these because I want to make sure you have the correct, no, it doesn't count for a grade. However, if you look at the assignment, you'll see there's a little spoiler alert here. Ms. Herman works hard making questions and likes to reuse them on quizzes. So you might see these again, and might is like a very hard, like, yeah, you're probably going to see, yeah, you're going to see at least a few. All right. So you might see them on a quiz again. So next week's quiz, you probably want to have good notes. Okay. There's a second thing down here. If you keep going, we have a section about predicting products. So here I have given you what type of reaction it is and what the reactants are. So like the first one, the synthesis with potassium and iodine. What are you going to get? The type of, so focus on making accurate formulas for your predictions. We are going to do a Kahoot on Monday. And if you have all of these answers in advance, then you can put in your answers as we go on the Kahoot and you can see how many you get right. Do not attempt to balance them until you've verified your predictions. If you have predictions that don't have exactly the right formulas, like for instance, like magnesium chloride, magnesium makes 2, has a 2+. And so if I do magnesium chloride, that means I need 2 chlorines because each of them only has 1 minus. All right. If you have an improper formula, then balancing it can become much more difficult. So yeah, so make sure that, so go ahead and, so you can, not for a grade, predict the products, check your answers on Monday, and then you will have all correct answers just in case Ms. Herman uses some of these on the quiz on Friday, next Friday. Okay, I'm going to stop sharing my screen so I can see all of you more easily. Okay, any questions or things that I should go over from Kahoot? Or that material 5 practice? Thank you for the no. It's so nice to know that people are there. Okay. So we're going to take another break because we're going to really shift gears. What we're going to do next is we're going to take a look at this assignment. Does it burn? Because that's this week's assignment. We're going to take a look at section 3. Which is we're going to watch at least one video to talk about shared electrons in covalent bonds and what happens if they're shared unevenly. And then I'll give you some time to do some work and ask some questions. This assignment, I've moved it to be due Monday. If you have questions, you can send me an email with a question. I can help you out. Monday, I really want to spend working on pre-lab stuff, but we'll probably have time to answer some questions as well. And as always, you're always welcome to turn something in. You're always welcome to turn something in half done. Get feedback from me and then take it back and then revise it and raise your grade, right? You can always do that. And I
Wait, so that last part is half of the credit of that assignment? That was like last questions?
If you turn it in on time, yeah.
Okay.
Yeah. You get half credit. See? At least then I know that you're thinking. All right, right now it's 11:22. Let's take 11:23. Let's do a 7-minute break. Get ready for section 3 of Does It Burn? And we'll start at 11:30. Does it burn be in your progress report? No, this one will not be in your progress report because it's due after the progress period ends. Okay. Hello, welcome back from your break. We're going to watch a video today about a type of bond. Here's what we know already. So we know that elements and atoms react in a way to create stable arrangements of their electrons. One way they can do that is by transferring electrons, right? So metals will lose electrons, non-metals will gain electrons, and that transfer of electrons makes them have a lot of charge, and then they attract each other because they have opposite charges. Those are called ionic bonds, and charged particles are called ions. There's also a type of bond called covalent. This tends to happen between nonmetals together, and co means together. Valent refers to valence electrons, so these are shared electrons. Now here's the thing, not all sharing is equal. So take a look at this picture for our video. On the left, I have a small green circle that has lines sticking out of it, making it look like it has legs and arms. However, it has no head. On the right side, I have a big red circle. It has lines sticking out of it to make it look like it has arms and legs, but also no head. Together, they are reaching toward this brown thing that could be a noodle. It could be a rope. I'm not really sure, but they're both grabbing onto it, looking like they're pulling from one side to the other. Which side do you think is going to win? Do you think it's going to be this little guy over here on the left or the big guy over here on the right? Okay, so when we're talking about polar covalent, we're talking about sharing of electrons that's not even. One atom is going to win in this tug of war, pulling the atoms more from the side. So you can say that they're not very good friends. They're more selfish because they're grabbing things. You could also say they're more popular because the electrons spend more time over on that side. And the other reason why we call them polar is because I have charge or have electrons on one side ends up being more negative. The other side ends up being more positive because the electrons are not there. And so I end up with poles, just like the North Pole and South Pole, opposite ends of the world, or poles like on a magnet, opposite sides of the magnet. All right, let's hear this person tell us about polar covalent bonds.
Polar covalent bonds. The big idea here is uneven sharing of electrons. We usually represent a covalent bond with a single line connecting two elements to each other. In this single line, there are two electrons being shared, one electron from either atom. It would seem that based on this structural formula that the electrons are being shared evenly.
Okay, so here we're looking at hydrogen on the left with an H, fluorine on the right with an F, and a line in between them. So we haven't done a lot of stuff with structural formulas, but we have used our little puzzle pieces. And in our puzzle pieces, you might remember that hydrogen has one arm sticking out where it wants to look for a friend. Fluorine with 7 electrons has one space looking for an electron. So it has one way that it can make a bond. So hydrogen and fluorine will each share that electron. So fluorine's electron will share with hydrogen. Hydrogen's electron will share with fluorine. And between the two of them, they have 2 that will share. And so in this, I have one line showing those two electrons that are being shared. Oh my God, it must be Friday. All right.
However, this is not always the case. Sometimes we have an element that is much stronger than another element. So it's almost like a tug of war going on between the electrons that are in the bond. Now, since both elements in a covalent bond are going to be nonmetals, they're both going to be pulling on the electrons, so they're still going to share. We just might have the electrons spending more time around one of the elements as opposed to the other element.
All right, so in our little picture, we have hydrogen on the left, just like it was in the formula. Fluorine on the right, just like it was in the formula. Who won the tug of war? It looks like more of that rope between, or noodle. First period really insisted that it looked like a noodle. So fluorine is a bigger atom. It has 9 protons to pull on it with. Hydrogen's only got 1 proton to pull on it with. So fluorine will pull those electrons closer to itself so that the electrons will spend more of the time over with fluorine.
Now, the measure of an element's strength is called electronegativity, and electronegativity is the ability of an atom to attract electrons to itself. Linus Pauling was the one who developed this scale of electronegativity, and his scale puts fluorine as the most electronegative element with a value of 4.0.
Okay. Are we going to use this table in this sermon? No, probably not. Do we need to know that it exists? Yeah. Do we have to use it? Not really. Mostly, I just want you to kind of take a look at it. So this is an abbreviated periodic table. It does not have the noble gases on the right. So that the far right column just has the halogens. It also has a huge mistake in it. If you take a look at this top row of main elements, I have B for boron, C for carbon, N for nitrogen, and D for oxygen. I don't know. That should be an O for oxygen, and then fluorine. These are all numbers that are like relative numbers of if I put these two atoms together, who's going to win? The one with the bigger number. So what we're pointing out here is that fluorine is in the upper right corner and it has a number of 4. And that's the biggest number in the table. So fluorine pulls harder on electrons than everything else. If you look at the things that are next to it, so things that are the next highest, so oxygen and sulfur are both 3.5. Nitrogen and chlorine are both 3. Bromine is 2.8. So like this upper right corner has a lot of pull. If I look at all these numbers, where are the smallest numbers? So if I look around here, they all have some pull on electrons. They all have positive protons in the nucleus, so they all attract electrons. But where the smallest numbers are over here in the bottom left-hand corner. Down here, I have francium, radium, barium, cesium, rubidium. They all have this 0.9, 0.7, 0.8 happening over here. If we think about this, this makes sense. Things on the left side of the table, they want to lose electrons. Why would they be trying to grab onto electrons, right? They're trying to get rid of them. So here they have the lowest ability to grab on, so they're going to lose them. Okay, you can watch the rest of this on your own, but what I mostly want to do is just kind of let you know that there's always this pull, that one's going to pull one more than the other. So I'm going to come back to my slides so we can take a look. Okay. Where am I in my slideshow? This is a slide I wanted first. Okay. I want you to recall an image that you may have noticed way back when in September. So in chapter 2, lesson 10, we're talking about the periodic table and how it's organized and things. And this image is on page 46. And what we learned when we were looking at the periodic table is that the upper right corner, except for the noble gases, are super reactive. So as we went to the ends of the periodic table, we saw more reaction on the ends. And specifically the upper right hand, the fluorine, oxygen, chlorine, bromine, those were more reactive. And notice that's also the same place where I have atoms that want electrons, right? So these are the most reactive and they're also the strongest at grabbing electrons. Then on the left, I have, on the bottom left, I have very reactive elements as well, all those alkali metals. And they also have the lowest numbers, right? They want to get rid of electrons. They hold on to electrons the least. So there's a correlation here, right? We see more reaction on the ends, and we also see greater ability to grab electrons on the right and get rid of electrons on the left. Okay, what does this mean for mixing things up? Okay. So when we talk about water, we have oxygen in the middle, and it has 2 hydrogens sticking out of it. You might remember that oxygen is in the upper right-hand corner, so it pulls on electrons really well. So the electrons are going to spend more time around oxygen than around hydrogen. So this means that the electrons are negatively charged more around oxygen. So oxygen will have a slight negative charge. And this little squiggly line is a lowercase delta symbol. So it's a lowercase Greek letter delta. It means that it has a little bit of charge. So it's a little bit negative. And the hydrogens have a partial positive charge because the electrons don't spend over there. Okay. Then, and here I just have this slide is also on page 2. This picture is also on page 215. So they tell us that the delta symbol, delta plus, partial positive charge on hydrogen and partial negative on oxygen. All right, so what does this mean and other things? If I have a big difference, then I end up with what we call polar, right? So this bond between oxygen and hydrogen is polar. And we have some examples down here. So hydrogen and fluorine, the one that he had in his presentation is polar because fluorine is going to pull on it a lot more. This number that you see in this scale is just them taking the difference of the 4 for fluorine and whatever hydrogen had, 2.1. So they find a difference and they call that polar covalent. If it comes out pretty even, like down here, then we would say, no, that's not enough. Especially if I have hydrogen and hydrogen, like they're going to pull equally. Hydrogen and chlorine, maybe a little bit different. Hydrogen and carbon, not very different. And this is just to tell you that there's kind of a whole spectrum. So some things are more polar or less polar, more charge or less charge. Okay, I think I want to skip to one slide. Okay. 45. Okay, we're almost at the end. Let me see what is the most important thing for me to talk about here. Okay, so if we're looking at bond types, things that are non-polar, they're both covalent, right? So they're both sharing. The difference is that polar has uneven sharing, right? So I end up with the electrons on one side more than the other, and it creates poles. Non-polar has even sharing. Because they're evenly shared, non-polar, no charge. There's no poles. There's no charge. Polar has some charge. Also, words you can think about is non-polar is symmetrical, and a polar means that it's asymmetrical or unbalanced. Okay, if I end up with such uneven sharing that the electrons actually get transferred, then I end up with ionic. Okay, so this has no sharing. So there's kind of a continuum here where nonpolar has even sharing, polar has uneven sharing, and then ionic, like that big kid, just steals the electrons completely. Ionic has a lot of charge. Okay, so something like water that has some charge, those opposite charges are going to attract each other. They're going to stick together. Ionic, these are going to stick together. So if I have something that is polar or something that's ionic, those things will probably mix together. And they'll stick together so much that something that's nonpolar like oil can't fit in. So that kind of gets to some of these answers about why do oil and water not mix. Oil is not polar. It has no charge. Water, polar, sticks to itself. It's so happy sticking to itself that it doesn't let the oil in. All right, so we will talk about this more on Monday, right? So we're gonna, kind of put all these things together. So let's see where we are. All right, this is our assignment. So reaction models. If you haven't finished these, you can look at the reaction models in the reference section on Google Classroom, and you can get your models to match. You can draw pictures or use chips and put those in. Either way is fine. Or you can edit these documents. That's fine. For chemical equations, I'm going to post, I thought I already posted, but let me see if I haven't posted answers. So you can make sure that you have all the right answers for, actually, I think it's in the Zoom recordings because it's in the slideshow that I post. So you can check your answers there. Ms. Herman, does that mean I can just copy my answers? Well, you could just copy answers, but is your brain working as much? Maybe it's working a little if you write things in. But the reason I provide answers is because I want to make sure that when you're practicing correctly. Okay, and then down here, attractions between molecules. So I hope we've answered this question, the difference between polar and nonpolar. In this question, explaining words or draw pictures what a polar molecule is. So water is the classic example, but if you want to branch out and look at something else, you can look at ethanol or hydrofluoric acid. That's the one that he had in his slideshow, or hydrogen sulfide. And then these two questions were in the last assignment. So if you answered these questions in the last assignment, you can copy and paste your answers here. But then add some more detail because we know some more now, right? We've had a few more days talking about it. So talking about why oil and water don't mix, and then what happens when salt dissolves in water. Okay, I'm going to go back up to the top here just to emphasize Miss Herman is not your only source of information. I work really hard to get a lot of different things here. So watch a video, read the textbook, do a simulation, read an article. There's a lot of stuff here so that you can take a look at things and get information, not just from me. Not to say you can't ask me, you can. All right, so before Monday, hang on, where am I? Somebody commented in the chat like, oh my God, how do you have most slides? Well, this is for the whole week, right? I do like 10 slides a day. But here we go. And no, when I post the slideshow, I don't post all 70 slides. I just post the ones that were for that day. All right. So what should I do between now and Monday? I should complete all sections of this assignment. I should work on previous work. So, and if you want to submit it today for inclusion on progress report, that's a good idea. So last week's lab, quiz 4 take or retake, and anything else you might have. Other things you should be doing to get ready for Monday is look for an email from me sent home to your families to tell you about materials you want to gather over the weekend for our lab next week. All right. And with that, look at that. I'm done 10 minutes early. Any questions? Okay. You are free to go to lunch. Please at least say goodbye or wave to me or put something in
Bye.
the chat before you
Wait,
go.
Miss
Thanks.
Herman?
Yes,
Good
Isaiah.